I don't know what he's talking about. They were nighttime.
That's not appropriate for class time. All right, here we go. All right. Oh, I'm gonna need a calculator today. Huh? Where's my stool? Over there. Okay. Weird. All right. Pardon me, dear. All right. So we are talking about areas of polygons today. We want to be able to calculate the area of a regular polygon. A polygon, which is any sided figure. So here we have an example of a 1, 2, 3, 4, 5, 6-sided polygon, a hexagon. And so we want to be able to calculate it whether it's got 6 sides, 7, 8, 9, 10, or 100 sides. And what you'll notice is when we look at this hexagon, we can divide it into a bunch of triangles. And so in order to figure out the area of any n-gon, a regular n-gon, what does regular mean? So all the sides are congruent, and that's kind of important. They have to be a congruent sides, congruent angles sort of thing. So all the sides are congruent. Because if they're all congruent, then all the triangles are the same size. And if we want to figure out the area, what we can do, the area is simply, hey, let's figure out the area of one triangle. If I figure out the area of one triangle, then what do I need to multiply by? 6 to get the whole area of the thing, right? Okay. And so that's a little bit tricky. We got to be a little bit careful. And to do that, we have to know a few vocabulary terms here. So the area of the polygon is the area of one triangle times however many triangles we have. That is the general formula we're going to use for this. But I do need to know a couple of other terms here. The distance from the center of the polygon to any side. So that's this dotted line here. That is called the apothem. I'm going to give it an A for apothem. A-P-O-T-H-E-M, apothem. The apothem goes from the center down perpendicular to a side. And I could draw it any direction. So I could draw an apothem here, and it's just always going to be perpendicular to that side that we're approaching. When it happens, also that apothem is going to break the large triangle up, split that opposite side perfectly. And then, of course, we also have from the center of the polygon to a vertex of the polygon. So you'll notice that we've got this circle circumscribed around that polygon. And that circle and this corner, sort of this vertex of the polygon, line up. So we call this a radius. So the radius of a regular polygon is the distance from the center to a vertex. And that's just because it also falls on the circle as well. So we can call it a radius, from the center to the edge of the circle, radius. And these are two pieces that we're going to need to know in order to figure out our area of a triangle. So what is the area of a triangle? What is the formula?
1/2.
Good. 1/2 base times height. Very good. And so we want to keep that in mind. And so what we're going to do is a little process here. These are from Delta Math. And so you can sort of really see what you're going to come across today, what's coming ahead here. So first I want to figure out how many sides I've got here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 sides. And what we want to do is, step 1, it says, create a right triangle by drawing and the opossum and radius. Well, I'm just going to start by drawing my triangle. So there's my first triangle. How many of these triangles are there?
9.
There's going to be 9 of these congruent triangles. And you could see if I kept drawing, we've got 9 triangles. 9 sides, so we've got 9 triangles in here, okay? But we want to create a right triangle like it says here, so I'm going to drop down from the center. I'm going to drop down my opossum. So there's my little opossum, and the reason I need that opossum is because that's my height of my triangle there. So I have to get that straight up perpendicular height. So I'm just going to call that H because that's the height of my triangle. You can see that we've been given a radius. The radius is 9. But I also need to figure out, if I'm going to find the area of this triangle, I need to figure out the base here as well. And so I'm just going to call that, I don't know, B, but it's not quite right. All right, so we need to do a couple of things. So I've got my triangle. I need to know my base and my height in order to find my area of my triangle. You're with me so far? Okay. Now, it says find the measure of the interior angle where the radius intersects the vertex. Let's see. There are 9 sides. What's the measure of that one angle, that at the top of my triangles? How would you figure that out? Yeah, 360 degrees divided by 9 sides. And what is that? 360 divided by 9 is 40. 40 degrees. So each of these little interior angles right here is 40 degrees. For all those triangles, that angle closest to the center is 40 degrees. What happens, do you suppose, when I dropped in this altitude right here, this height line? It got split, absolutely. And so now each of these little guys is 20 degrees because it got split right down the middle. You good with that so far? Okay. So what I have is I have a triangle, a right triangle right here. It has a height. It has this radius of 9. And I need to figure out this little base too. Maybe I'll do that. Maybe I'll do a capital B for big base. There we go. I want to find that little base. So what I've done is I've taken this triangle right here and I've just enlarged it so we can see pretty clearly what's going on there. And it has a nice little 20-degree angle at the top. So I need to figure out what this little bottom piece is, and I need to figure out what the height is. And the way that I'm going to do that is using SOHCAHTOA. All right, trigonometry, because I have an angle measure right here of 20 degrees. And let's say I want to find this base here, that little b. Which trig function would I use? I have a hypotenuse, and I have this side. What would you call this side? The opposite, okay. Opposite and hypotenuse is sine. So we're going to set up a sine equation. Sine of my 20-degree angle, sine looking from my 20-degree angle is opposite over hypotenuse, so b over 9. And how do I get b by itself?
Divide by 9.
Multiply by 9. Yeah, we're going to multiply that 9 to the other side, so we get 9 times the sine of 20 degrees equals b. And so we're going to go ahead and go to our calculators. And what mode should we be in? Degree mode, because we are using degrees. So we want to make sure first that we're in degree mode. So make sure that you're in degree mode. You go to the mode button. All right. And then let's see, 9 times the sine of 20 degrees is 3.07818. I'm going to tell you guys for delta math, don't round, okay? We're going to pull that whole decimal in when we do our math, so we need to be a little bit careful. All right. So first of all, that was little b. Little b was right here, just this little bit. How do I get the whole base of the triangle? Oh, times that by 2. Very good. So we're going to double it to get big B. We need big B. So all I'm going to do is take my answer and times by 2. And that gives me 6.15636. 6.15636. All right, are you with me so far? What's the other piece that we need? We need to know the height. So again, we can set up a little trig problem here. So now I'm using the height and the hypotenuse. Which trig function would that be? Cosine. Adjacent and hypotenuse is cosine. So we're going to do cosine according to our 20-degree angle is equal to adjacent over hypotenuse. Adjacent h over hypotenuse 9. So cosine would be adjacent over hypotenuse, h over 9. And then how do you get h by itself? Times 9 to the other side. So 9 times the cosine of 20 degrees equals our h value. Let's see, 9 times the cosine of 20. I get 8.45723. So now I have my base and I have my height. And if I want to find the area, what's the basic formula to find the area of this thing? Yeah. So 1/2 times my base, which is 6.15636, times my height of 8.45723, times the number of triangles. How many triangles do we have? 9 triangles. So times 9. I squeezed it right in there. Okay? So 1/2 base times height times the number of triangles. So I'm going to use my calculator. So 1/2 times my base number was the 61536. I'm just going to pull it from above. So go up and highlight it and then hit enter. So there's my big base. And then my height value was the 8.4. So I'm going to grab that one. And then I'm just going to times by 9. So I encourage you, don't round. In math, we never round. In science, we don't round until the very last thing, okay? Otherwise, if you round too many times, you're totally off at the end, okay? So we don't round until the end. And so we get an area of 234.296 units squared. I don't know what the units are, but. All right, so 1/2 big base times height times the number of triangles is a basic formula there. Area of a triangle times the number of triangles. Okay, you have questions for me right now? Okay, let's try a couple more. Let's look at number 5. How many sides? 8. 8 sides, yeah. If there's 8 sides, how many triangles are there? 8 triangles, okay. And what's the measure of our little interior angle there? 360 divided by 8. All right, so 360 divided by 8, and I get, 45. Oh, that's nice. 45 degrees. Now, again, I want to draw my working triangle here. So there's my other triangle. I'm going to go ahead and drop down my altitude. What happened to my 45-degree angle when I dropped in that altitude? Got cut in half. And so now it's 22.5. So now these angles are 22.5 degrees. All right. And I'm going to go ahead and label, oops. Hello? Okay. Bye. Your binder's here. You can get it later when we're done. Oh, you need it for notes. Go get it. There you go. All right. And so I'm going to label my height here, that I need to figure out the height. And I need to know the big base. I'm going to give it a capital B for that big base of the triangle. And that little triangle in there is just that little base. So there's my little base. Here's my height. Here's my 22.5 degree angle. And my radius, they told me, was 6. So that is that number 6 there, the radius they gave me. All right, so there's my little triangle I'm going to use with some trig. So again, this is the hypotenuse. How do I find my big little base here? Sine
22.5 equals 6.
Opposite over hypotenuse. Sine of your angle equals the opposite over the hypotenuse. So little base over 6. And then how do you get the base by itself? Times by 6. So 6 times the sine of 22.5 equals our little base. So 6 times the sine of 22.5, and I get 2.296. But that's just a little base. How do I get the big base? Times by 2 to get the big base. So I'm going to times that by 2, and I get 4.592. 4.592 for my big base. So I needed that one, big base. That's a good one to know. All right, so there's one thing I needed. How do I figure out the height? Cosine, adjacent and hypotenuse is what I have now. So cosine of my 22.5 degree angle is adjacent over hypotenuse, h over 6. All right, how do I get the h by itself? Times by 6. So 6 times the cosine of 22.5. So 6 times the cosine of 22.5, and I'm getting 5.543, yada, yada, yada. So there is my height of my triangle. All right, and so now if I want the area, it is 1/2 big base. So that's 4.592 times my height, which is 5.543, times, how many triangles?
8.
8 triangles times 8 triangles. 1/2 base times height times the number of triangles. And again, I'm just going to pull all those numbers right from my calculator. So 1/2 times the 4.592 times the 5.543 times the 8. So this is where these calculators come in super handy. And so we get 101.823 units squared. I don't know what they're going to have you round to in Delta Math, so you're going to have to read carefully. All right. Questions so far? It's really not. I'm just hoping we do enough that you get it. So, is it all the same? Well, minute differences, but this is the hardest it is. So I like to start with the hard stuff. Okay, so turn the page. We're going to do 2 more. All right, number 7, and then you'll notice that I left space for you to do your work on paper for the Delta Math too. So, all right, let's see. Counting the sides here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. How many triangles? 9 triangles. And in that triangle, I need to know the interior angle measure there. How do we get it? 360 divided by 9, which turned out to be 40 degrees. So that's 40 degrees. And now I'm going to draw my little triangle. So I'm going to draw my little radii right there. And oh, I don't know the radius now. They're giving me the height, So I still have my little base, and I still need to find the big base. So now my triangle looks a little different because they're giving me slightly different information. So now I don't know what my R radius is, so I'm going to write that in pink. And then I have my little base, but I do know the height of my triangle is 13. Do I need to know the radius?
Nope.
I don't need to know the radius. It doesn't. I have my height and I need to know the base. So that's kind of nice. So this is slightly less work. What is our little angle right up here? 20. We got it split in half, so this is now a 20-degree angle. Both those little angles got split by our opossum there. All right, so to figure out little b and big B, let's see. What do I have here? I have opposite and adjacent now. So what trig function is opposite and adjacent? Tangent, TOA, yeah. So tangent of my 20-degree angle is opposite over adjacent. So b over 13. All right, and how do I get b by itself? Times by 13. 13 times the tangent of 20 degrees equals little b. So 13 times the tangent of 20 degrees is 4.731. That's little b. How do I get big B? Times by 2. So big B, just going to times by 2, is 9.463-ish. So there's big base. Hey, I have my big base now. I have my base. I have my height. So I can find my area. So 1/2 big base, 9.463 big base. My height is 13. And then how many triangles? 9 triangles. So I like to do that. Doesn't that make it seem super easy now? 1/2 times my 9.463 times the 13 height times 9 triangles. 553.599, rounding that 8 to a 9 if it was round to the thousandth. All right. Questions on that one? Now it seems really easy, right? Okay. All right, last one. Let's see, 1, 2, 3, 4, 5 sides, which means there are 5 triangles. And what is that interior angle measure? 72? That sounds right. So 72 degrees. Now, if I split that with that lovely little opossum they gave me of 17, 72 divided by 2 is 36 degrees. So those got split now to 36-degree angles. So I want to find my little base and then get my big base so I can find the area of that whole triangle. What? You good? Okay. So now if I have my 36-degree angle, then I have my opposite and I have my adjacent of 17. So opposite and adjacent is tangent of my 36-degree angle is opposite over adjacent, b over 17. I'm going to go ahead and multiply by 17. So 17 times the tangent of 36 degrees is 12.35. And then what do I need to do? Times it by 2. Got to double it to get big B. Times by 2. And I get a big B equal to 24.702 something. So there's my big base. My height equals 17. And so now we can find our area. The area is 1/2 big base times our height times the number of triangles, which is just 5. So 1/2 times my 24 times the 17 height and the triangle's 5. So 1049.854. All right. Area is 1/2 big base times height times the number of triangles. Do you have questions for me? Doubts and asks. All right.